Okay, today we're going to check a failed inverter. So we've got this inverter here in front of us. Now we can see that it is actually disconnected. However, one of the first things you do when you come to a failed inverter is you assess, see if it's actually live. So we can see in front of us that the inverter is unresponsive. However, do we know that it is in fact dead? So what we'll do then, we'll then actually check on these supply terminals. If there is a cable going to it, are we getting voltage? Very first thing we do. Okay, so if we establish that we've got voltage, then we further expand on that and say, okay, can we have a look at the parameters? Can we look at the fault codes? Is there a fault code shown? So we can, in some ways, try and interrogate the drive to see exactly what's going on with it. So if we can, or sometimes can't do that, then therefore the best way is to isolate this from any sort of power, and therefore then check to see if it's dead, and also make sure that the DC voltage is discharged from the terminals. And that should take about 10 to 15 minutes, depending of course on how long this has been live. So, firstly, looking at this, as we take off the front cover, what we're going to ask ourselves is it wired correctly? So therefore, is there any stray wires in the wrong terminals? Is there any damage to these terminals? Is there any melted wires? Also, have we got the right supply voltage actually on this drive for the rating of the drive? So, once we're satisfied with that, then we're going to then expand further on that and also do what's called a diode test. So a diode test is a very simple test you can do. And what we're going to be doing is we're going to be first of all assessing the input bridge. So that's going red lead to DC plus and black lead to the input phases. So we see from there we are charging up the capacitors here. So therefore, if we then go to the other side of the input bridge, we should get a stable reading, which we do. We therefore then reverse the leads. So black lead now is on DC positive and red lead is on the input phases. So again, we're expecting a stable reading and we've got it. And then black lead on DC minus. And therefore then we can see that this is actually in fact charging up the capacitors. So that is the test then for the input bridge. We then, to further check this, then we test the IGBT, so we're testing the outputs. So again, very same test. It is red lead on DC plus, black lead on the phases. And again, we can see that charging up. And that's now going to over limit now because the capacitor is sufficiently charged. So red lead now on the minus, and black lead on the phases. So again, we should have a stable reading, which we do. And again, to make certain, we reverse the leads. And again, we can see we've got a stable reading. And then just to further check, we'll then see, there we are, yes, we can see that this now is over limit. So therefore, that is the diode test, and therefore that is how you check a failed inverter.